Good morning. This is your notes video for Monday, January 5th for chemistry and chapter 7. And we're looking at 7.3 molecular geometry and Lewis dot structures. As a review, we're talking about making Lewis structures. You make your Lewis dot diagram and then you connect them so each atom has a full octet. And then we talked about isomers, are different molecules with the same chemical formula. And we also talked about double and triple bonds. We know atoms can share 2 electron pairs to make a double bond, or 3 electron pairs, 6 electrons total to make a triple bond. And we practiced doing Lewis dot diagrams with double and triple bonds. We made acetic acid and formaldehyde, and you should have already made one for acetonitrile, and we'll go over that in class. And next, we're going to talk about how molecules are 3D and their implications for that. Okay, this should be new, so please write it down. Molecules are 3D. The 3D shape of molecules determines how it bonds and its properties. For example, 3D dimensions of a biological molecule determine how they act in the body. So, for example, the 3D shape determines if the medicine is an effective cancer drug or it does nothing. So how its shape is really is important in chemistry because it determines how it reacts, and that's most of chemistry. You can use a 2D Lewis structure to predict the 3D molecular structure of any compound. This determines, or relies on the VSEPR theory, which is actually VSEPR, valence shell electron pair repulsion, which is a theory used to predict molecular geometry, which is the shape of a molecule. It says the shape of a molecule is dictated by the repulsion of shared electrons and unpaired electron pairs. So please write that down. So electrons push away from each other, and that's something we know, but that has an implication. Bonds and unshared electron pairs are known as regions of electron density around an atom. So a bond or an unshared electron pair are both known as regions of electron density. So if there's an atom with 2 regions of electron density, it's going to form a linear shape. Okay, for example, carbon dioxide and acetylene. See if you can draw the Lewis structures of carbon dioxide and acetylene. And if you're stuck, make sure you leave space. Atoms with 3 regions of electron density form trigonal planar shapes. So, ethene, C2H4, and boron trifluoride, BF3, take a moment and see if you can do Lewis structures for both of these, and also make sure to leave some room for corrections if needed. Okay, lone pairs are electrons that are paired up but not involved in a bond. And that's going to be important because once we get to 4 regions of electron density, we'll have to take into consideration lone pairs on some of the shapes. So, an atom with 4 regions of electron density could form a tetrahedral shape. So see if you can make the Lewis structure for CH4, methane. And again, leave some room if you need to make any corrections. Or areas of 4 with 4 electron atom with 4 areas of electron density could form a trigonal pyramidal shape, like ammonia. See if you can form the Lewis structure for ammonia. And again, leave some space. And the third type it could form is bent. So see if you can do the Lewis structure for water, and again leave some space. Okay, so also in your book, it talked about nutritional facts, health, and chemistry. So what do you need to know about calories? What does that have to do with chemistry and health and as an unit of energy? Okay, fats, saturated and unsaturated. What do you need to know about it for chemistry and for health? What are cis fats versus trans fats? Carbohydrates. What are monosaccharides, disaccharides, and polysaccharides? Please make sure you're writing all of these down. Proteins and amino acids. How are they related? And finally, what do we need to know about a healthy diet? And that concludes our Chapter 7 notes. Good job. Bye.